Welcome to Spring LIB.
Okay, so for this problem, we have Newton bright and dark rings, and we have a planoconvex lens. So let's draw it. So before we dive into the specifics, so we have some kind of surface. Let's see. I'm gonna double check and look at the picture. So this is supposed to be figure 18. I'm gonna pause the video while I find the figure. Okay, found the figure. So here's the thing that it's resting on, and here's the lens. And basically, the light is going to kind of come through, and then it's going to come through here. And depending on this thickness, so let's go ahead and maybe draw that. So it's going to reflect off of, light will reflect off of this surface, and then some of it will optionally go through the lens and exit into the air and then get reflected off of this surface. And we're concerned with the interference of these two. And I drew them separately because you can't draw them on top of each other, but these could be on top of each other. So we're concerned with reflecting off of this surface and then this surface and the phase difference between these photons. And so I'll worry about the 31 part of the problem in a second. Let's just kind of get our bearings for what's going on. So we know that for, let's see, are we concerned with constructive or destructive? Well, let's say that we're concerned with constructive interference. Then we know that the condition for constructive interference is delta phi is going to be some even multiple of 2 pi. So that's so m is going to be an integer. I'll write it in the fancy math way, element of the integers. And the phase difference between these two is going to be given by, so if this is the second and this is the first photon, it's going to be so the additional phase that this accrues is going to be, in comparison to this, is going to be the phase it accrues as it goes through this air. So that's going to be, it's just going to be 2 pi times whatever thickness it is at a particular position on the lens. And it's going to go through it twice. So that's times 2 divided by lambda. And this just comes from, in general, for sine waves, phi, the spatial phase is 2 pi over lambda times x. So it's kind of some old trig. And we can keep in mind that we don't have to modify this lambda because it's traveling through air. So we can say lambda is equal to 560 nanometers. And yeah, so that's going to be, this is the condition for constructive interference for m. It's actually m cannot just be an element of the integers. It's more of the element of the natural numbers. I guess just not including 0, because I guess that would be the case of 0 thickness. So we want to look for non-zero thicknesses. And so this kind of enumerates all the instances. So let's go ahead and write down kind of a formula for the thicknesses, and just simplify this a bit. So let's cancel some 2's and pi's. So 2 pi, and t is going to be lambda m divided by 2. And I think that's it. Okay, yeah, and then this gives you all the thicknesses for which there's constructive interference. And so basically we see it 31 times. So we know that we can say that m is equal to 31. And therefore, if we plug in 31 here, then we can say that it's that the thickness is going to be, so it's going to be 31 times 560 nanometers 31 times 560 times 10 to the minus 9, and then we want to divide that by 2. And so we get 8.68. So actually, and then, yeah, so that should be our thickness. One question I actually had, this is very like kind of getting into the details, but I want to make sure I got this completely right. So let me finish writing that. I might have to revise it. Oops, that should be just meters. Shouldn't think while I talk. Okay, so I just want to know, does this thing end on a dark or a bright? So which one's going to come first, basically? So I think that a destructive interference should come first because that requires them to be pi apart. Let's see, is that actually true? Let me just stop and ponder. So, okay, so as this one comes and reflects off of here, so our first photon is this, and it reflects off of here, and there's no phase change. So this one doesn't have any phase change. So this one, as this one reflects, it always undergoes a phase change, and so we need to kind of increase this thickness until there's a constructive interference. And so the first thing that there's going to be, I would say, is destructive interference. Well, I guess they're saying don't count the black center. And so the center, why is the center of an airy ring going to be black? Well, you have a photon coming in, again, no phase change, but as it reflects off of this surface, there is a phase change. So that's why it's going to be black. So then it's going to get black and then sort of go towards bright. So it's going to be bright, dark, bright, dark. So if there's exactly 31 bright and 31 dark, not including the center ring, then it should actually end on a dark. So then perhaps I should have done this for a dark ring. Although I saw that this actually is the right answer, I think, given the book. Let me just double check that. Maybe it's a very negligible difference. I'm guessing that it is, and I'm just kind of splitting these hairs. If you wanted to get it more exact, you would use the condition for destructive interference, just because we know that the last ring is going to be destructive, right? We're going to have the center be dark. The first one's going to be light, then it's going to go light, dark, going to go dark again, light, dark, light, dark. If exactly 31, again, we'll end on a dark. So that would be a way to revise it. But since I'm getting the answer already in the back of the book, I'm going to stop here.